After learning writing homogeneous differential equations in terms of an equation with differential operator and then transforming it into an auxiliary equation, we now need to solve them using the auxiliary equation. But this time, this equation here is already identified that the roots are distinct because there are four different cases. The first one is if the roots are real and they are different from one another. That's the purpose of this video. The next set would be if there are roots or real roots that are of multiplicity or repeated real roots. You also have instances where our roots are imaginary and also an instance where there are repeated imaginary roots. So just a disclaimer, already mentioned that this should have distinct real roots, but of course for some cases we don't know that. But just for the purpose of discussion here, this example, the second order derivative of y minus the first order derivative of y minus 2y equals 0 is said to have distinct real roots according to its corresponding auxiliary equation. So here are the steps. The first one is of course writing this in an equation with differential operator. We had this already on the previous videos, just rewriting it here. We have here d squared minus d minus 2, you will have here times y equal to 0. Okay, then we will introduce here the auxiliary equation f of m equal to 0. Hence, from this, you will have m squared minus m minus 2 equal to 0. In solving for this, we simply need to solve for the roots of this given equation or solve for the possible values of m. Now, of course, looking into that, there are many ways to solve, especially if this is an example of a quadratic equation. We can also use the quadratic formula, or in this case, we can simply use factoring here. When we factor this, we simply need to look into the correct factors. You can use here the AC way. Okay? AC is 1 times negative 2, which results to negative 2. What are the factors of negative 2 when added will result to your middle coefficient here of negative 1. This is actually negative 2 plus 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. Hence, these are the values you're going to pair with m. So the roots are m minus 2 and m plus 1 equal to 0. Of course, if you're not confident with this, you can always use the trial and error. Think of any value or real number value that when substituted to m here will result to 0. These are the two because if you have, you will see it later on. As we use the zero factor property, you have m minus 2 equal to 0 and m plus 1 equal to 0. So the roots are, the first root is positive 2 and the second root is negative 1. Checking, substitute that here. So you have 2 squared is 4 minus 2, check, that's equal to 0. For the second item, you have negative, the square of negative 1 is 1. Negative of negative 1 is positive 1. Minus 2, it's still equal to 0. Okay, so please review your factoring for this type of examples. Now that we are sure that our roots are distinct and real as mentioned here, now we can structure our solution. Now the solution for distinct and real roots follow this general form. You have y is equal to c sub 1, any constant, e raised to the power of your first root times x, plus c sub 2, if there are two roots, you have e to the power of your second root x, plus dot dot dot, until you reach c sub n, if there are n number of roots, times e to the power of m n x. Of course, our equation here, our auxiliary equation, is a quadratic function. Hence, we only have two roots. So we will end up until here. And substituting that in our general solution, our solution here for this given homogeneous differential equation is y equal to c sub 1, any constant, e to the power of your first root, you have 2x, plus c sub 2 e to the power of your second root negative 1 x, or simply you will have here c sub 1 e to the power of 2x plus c sub 2 e to the power of negative x. This is the solution of the given differential equation. Now, before we end, a disclaimer, of course, you could always interchange the two. If you were going to decide that you will write here negative 1 and this is your 2, negative 1 and then 2, it's still the same because c sub 1 and c sub 2 are any constant. And at the same time, since they are both roots of our auxiliary equation, it doesn't matter which root or which value of m is written first. But let's just stick to what we did since we labeled it already earlier that our first root is 2. So we have it here. And our second root is negative 1. So we have it here. This would be our final answer for this case. But of course, as mentioned, they can be interchanged as c sub 1 and c sub 2 are arbitrary constants. Thank you very much for watching.